Very good evening, class. How are you all? Everything fine at your end? So, in today's lecture, we will continue with PCR, right? DNA PCR and DNA isolation. Yeah, I'm fine, bache. I'm good. Usually at the home nowadays, um, reading about review papers and all this stuff. Students who have not subscribed to this channel, please subscribe. It will really help me, though I have achieved 1K just recently, but still it will really help me to go more up. And like these videos, this also help us. Okay, it's hanging. So we should not wait much, and we should start with the DNA PCR. So you might be aware of DNA PCR or DNA isolation, but might be not aware doing them in practically in the classroom. So our focus will be on that in our upcoming lectures today. Um, okay. And students, those who have I just want to say that has um, some issues, please do contact me after the class at 9 p.m. I will try to resolve them. I resolved one issue with the one girl. So they were fine with that. They don't have much problem. And so as I said already, in this MBBT course, in the first objective, if you have read that, so it was basics of MBBT. The day first is mainly focused on the basics of MBBT. So it will not go beyond that. So we are just still at the basics of principle of MBBT. So it was written under the course instructions. The one day we will finish with this part, then we'll continue with the cell culture technique and microscopy, and we will go for further um, CRISPR-Cas9 on and other various more advanced techniques day by day. So this is how I have planned the lecture. So things will gradually go up. If still somebody have anything, any issues, feel free to contact me. I will happy to resolve your issues. So we are here to make things done clear with the peace, and um, nothing as in like like a typical teachers are who just want to force things. So this is what I have learned from Germany. So when I was in during the Germany part, no teacher had even screamed at us. No one has forced us to give some specific exam. Sometimes we skip our exams. They don't say anything to us. They said when you have time, you can give your exam then. So the universities at the Western world, they are very student friendly, and they care about student a lot rather than teacher or faculty himself or herself. So this perspective I always keep in my mind, that the students should be satisfied in our lectures because they are here to learn something, to gain knowledge, right? If you are not satisfied, then we can resolve it, we can solve it by talking, by speaking to each other. So what are the issues, we can um, help it out each other. We are all mature, and everything in the life also, something is not you know it's not the way it's going on, so it could be resolved by just talking with someone. So stating that, let's start with PCR. I hope we are all on the good track now. Nothing seems fine with everyone. If anything, is there any issue or anything that you don't like or you want to get improve on that, please suggest in the chat box, or you can write me also personally. So I had still some questions. So I was today just busy in some uh, huge amount of review articles. I'm still not able to answer them, but and also the upcoming days, this Friday, Saturday, Sunday, I might be having workshops under the EduFabrica, so I will be totally jam packed during the weekend, so there will be no time during that time also. Anyhow, we will manage. So as we know, PCR is a technique in order to identify a large amount of sample of a DNA sequence for further testing. It was discovered by Dr. Gary Mullis in 1983, and there was first publication by Cetus Corporation, which appears in the Science publication in 1985. Then in 1986, purified Taq polymerase is first used in PCR. In 1988, then Perkin Elmer introduced the automated thermal cycler, and then 89, science declares Taq polymerase molecule of the year. So purpose of this PCR is to amplify a lot of double-stranded DNA molecules with the same size and sequence by enzymatic methods and cycling conditions. So as we have discussed in this, there is a denaturation is happening with a temperature of 92 to 94 degrees Celsius, and then the double-stranded DNA melts away. So you have single strands afterwards. So at 92 degrees Celsius, everything got separated. Then annealing in this around 50 to 70 degree temperature, primers bind to the complementary sequence like so. Then extension is done with a temperature of 72 degrees Celsius times 0.5 to 35 minutes. So all the your nucleotide polymerase and these will nucleotides will join them and will form a complete template out of it. So you have products of extension like this. So overall, after the 35 sequences, 35 cycles, you will have millions of copies of the same DNA. So it will your component that it will include will be magnesium chloride, buffer, DNTPs, primers, DNA polymerase, and your target DNA. So you add some amount of each of them and make a cocktail, and then further it could be used for reactions in the thermal cycler. So in this region, for the basic requirements are you need a DNA sequence of target region, then typically 20 to 30 base pairs in the size, and this can be readily produced by commercial companies. Can also be prepared using DNA synthesizers. Then thermostable DNA polymerase, example Taq polymerase, which is not inactivated by heating to 95 degrees Celsius. Then DNA thermal cycler, machine which can be programmed to carry out heating, cooling of samples over the number of cycles. So many applications are there like molecular archaeology, epidemiology, ecology, bioinformatics, site-directed mutagenesis. In many ways it could be used. So this is the instrumentation we use. This is the normal thermocycler PCR. This is the most oldest one. These are the most latest one, light cycler, and this is the 4-in-1 light thermal cycler. So you can run 4 reactions at same times. So that was it. Very simple, small introduction about PCR, right? Okay. Now I had them earlier in my. Oh, 35 sequences, 35 cycles, you will have millions of copies of the same DNA. So it will your calcium, your component that it will include will be magnesium chloride, buffer, ENTPs, primers, DNA polymerase, and your target DNA. So you add some amount of each of them and make a cocktail, and then further it will be used for detections in the thermocycler. So in this region, for the basic requirements are we need a DNA sequence of target region. I think there's a lagging going on. And typically, today, students, there's some lagging going on with the internet. Whatever I'm speaking, it's going 10 minutes late. So I don't know what's the reason behind it.